Let's talk about solving radical equations. There are 4 steps that I'll want to follow. Number 1, isolate the radical. So if it's a square root, cube root, whatever root, I want to isolate that, get it by itself. Number 2, bring both sides, so the left side and the right side of the equal sign, to the power inverse to the radical. So if it's a square root, I'm going to square both sides. If it's a cubed root, I'm going to cube both sides. If it's a fourth root, I'm going to bring both sides to the power of 4, and so forth. 3, simplify and solve. For quadratics, I want to set this equal to 0, factor or use the quadratic formula. For cubics, I'm going to try setting this equal to 0 and factoring. And then 4, this is important, I want to check my answers and exclude extraneous solutions. What this means is I may get some answers that are not actually answers. They kind of just look like they might be. But when I go to plug them in, which you'll see later, I get something very strange sometimes. So let's start with number 1. Examples. Let's say I've got 2 plus the square root of x plus 10 equals x. So I want to isolate this square root. That means I'm going to subtract 2 to start things off. All right, so I've got the square root of x plus 10 is equal to x minus 2. Next, now that I've got this isolated, I'm going to bring both sides to the power of 2 since this is a square root. So I'll square both sides. Over on the left, I'll have the square root of x plus 10 squared. So square root of something squared is that something. This will be x plus 10. On the right side, I've got x minus 2, this whole thing, squared, which is not just distributing and saying x squared minus 4, because what I'll need to do is multiply x minus 2 to itself. Now, if you can do that in your head, great, go ahead and do so. Otherwise, I can just do a box over here too. Where this will be x minus 2 and x minus 2. So x times x is x squared. X times negative 2 is negative 2x. X times negative 2 is negative 2x. And negative 2 times negative 2 is positive 4. So this will be x squared minus 4x, combining like terms, plus 4. All right, now let's bring everything to one side and get this equal to 0. So I'm going to do that all in one step. Let's subtract x from both sides, and let's subtract 10 from both sides. X squared minus 5x minus 6 is equal to 0. Okay, now we're ready to factor. So a equals 1, c equals negative 6. 1 times 1 makes 1. For negative 6, that's 1 times negative 6. 2 times negative 3. I could do 3 times negative 2. And then 6 times negative 1. I don't need the reversals here because a equals 1. All right, testing things out, I need to get negative 5 in the middle. So if I did 1, 1, and 1, negative 6, multiply the outsides, 1 times negative 6 would be negative 6. Multiply the insides, 1 times 1 is 1. Negative 6 plus 1 is negative 5. Okay, so then this is, I can already tell you, 1, 1 would be 1x or just x, and 1x or just x over here. 1 negative 6 would be plus 1 minus 6. And this is equal to 0. Which means splitting this up, if these two multiplied equals 0, then at least one of these is equal to 0. So that could be x plus 1 equals 0, or x minus 6 equals 0. Solving for each of these, I'll get x equals -1 or x equals 6. Now, I don't want to box these right away because they might be correct, but they also might be an extraneous solution. Either of them could be extraneous. So what I need to do is I need to take this x equals -1 and x equals 6, and I need to go ahead and plug this in to the left side and the right side and see if I come up with a true or false statement. So what I'm going to do here is let's bring up a calculator. And what we're going to do is just plug this in. Okay, perfect. Let's bring that over here. And say 2 plus the square root of x is going to, let's plug in -1 first. -1 plus 10. All right, that is 5. But the right side, just plug in x equals -1, that would be -1. Well, 5 is not equal to -1, so that's a false statement. So that means x equals -1 is not a real solution. This is an extraneous solution. Whereas if I go to plug in 6, watch what happens here. I've got 2 plus the square root. This time I'm plugging in 6 plus 10 here. That's going to be equal to 6. And the right side is x equals, well, just 6. So 6 equals 6. This is a true statement. Therefore, this is my solution. All right, let's try another one. X plus 6 to the 1/2 minus 2x minus 4 all to the 1/2 equals 0. Okay, the first thing I'm going to do is recognize that 1/2, the power of 1/2, this is the same as saying the square root. So the square root of x plus 6 minus the square root of 2x minus 4 equals 0. Now what I'm going to do is I'm going to add the square root of 2x minus 4 to both sides. So I will get x plus 6, the square root of x plus 6 is equal to the square root of 2x minus 4. Now I've got, technically each of them is isolated, so I can square them. And so the square root of something squared is just that something. So this will be x plus 6 equals 2x minus 4. Same thing here, the square root of something squared. Let's bring the x's to one side and just the numbers, the constants, over to the other side. I'm going to subtract x from both sides. This will be 6 is equal to x minus 4, and let's add 4 to both sides. I'll get x is equal to 6 plus 4 is 10. Now again, I'm not going to box this just yet. What I want to do is I want to go back to my original statement here, original equation, and I'm just going to plug in what I find, x equals 10, see if this is true or not. So when I plug in 10 plus 6, that to the 1/2 minus 2 times 10 minus 4, all to the 1/2, it should be equal to 0. Let's see if that happens. I've got 10 plus 6 to the 1/2. And then I'm subtracting 2 times 10 minus 4 to the 1/2. Now this should be equal to 0, otherwise this is an extraneous solution. And it is equal to 0. So x equals 10 is my solution. All right, then I've got this third example, the cubed root of x plus 2, and then outside of that, plus 7 equals 5. So let's start by isolating my radical. So let's subtract 7 from both sides. This will be the cubed root of x plus 2 is equal to 5 minus 7 is negative 2. Once that's isolated, I've got the cubed root here, so I'm going to bring both sides to the power of 3. The cube root of something cubed, that's just going to be the something in the middle there, x plus 2, is equal to negative 2 to the third power. So that's negative 2 times negative 2 is 4 times another negative 2, that's going to be negative 8. And then subtract 2. So x equals negative 10. Now I'm not going to box that yet. I'm going to take that, I'm going to plug it in to my original, and I see I've only got x's on one side here, so I'm going to plug it in here, and I should get 5. If I don't get 5, then this is an extraneous solution. So let's go ahead and try that. For cube root, I'm going to do 10, negative 10, like this, and then plus 2 to the 1/3 power, and then plus 7. So this here should be equal to 5, otherwise this is an extraneous solution, and it is equal to 5. So that means that this is a good solution. All right, let's do one last problem. Here I've got the cubed root of x minus 5 equals x plus 1. So this is actually already isolated for us. This is great. So that means I just need to bring both sides to the power of 3. Let's rewrite this. Cube root of x minus 5 is equal to x plus 1. And what I'm going to do, bring both sides to the power of 3. Now the left side is not so bad. Cube root of something cubed. As we know, this will just be x minus 5. But the right side, this is x plus 1 to the third power, which again is not as simple as just distributing this power of 3 and saying x cubed plus 1 cubed, so x cubed plus 1. What I actually need to do is x plus 1, the whole thing, times itself, and then times itself again. So I'm going to start off by taking 2 of those x plus 1s. And over here, we'll do x plus 1 times x plus 1. This is x squared plus x here plus 1. Combining like terms, this is x squared plus 2x plus 1. Now this is just 2 of these x plus 1s multiplied together. What I need to do is take the product, x squared plus 2x plus 1, and multiply by a third, because this is cubed, x plus 1. So that means I'm going to do yet another box. This time, I've got x plus 1 here, and then x squared plus 2x plus 1 here. X times x squared is x to the third power, x cubed. X times 2x is 2x squared. X times 1 is x. 1 times x squared is x squared. 1 times 2x is 2x. And finally, 1 times 1 is 1. Now notice I've got 2 terms with x squared here. And I've got 2 terms with an x here. So I'm going to combine those together. This gives me x cubed plus 3x squared plus 3x, then plus 1. So x minus 5 equals x plus 1 cubed is this whole thing. X to the third plus 3x squared plus 3x plus 1. Okay, now let's bring everything to one side. So I'm going to subtract an x from both sides. I'm going to add 5 to both sides. So let's move this over a little bit. X to the third power plus 3x squared plus 2x plus 6. This is equal to 0. Okay, let's factor this. What I'm going to do is I'm going to break this up, these 4 terms. I'm going to break them up into groups of 2 and 2. And I'm going to try and factor these 2 separately from these 2. So if I look at x to the third plus 3x squared, they both have x in common. Specifically, I can pull out an x squared. So I'm going to do that. And when I do that, I'll have x left over here plus 3. Okay, what about over here? 2x and 6, these are both divisible by 2, so I can take a 2 out. And when I do that, I'll have x plus 3 left over. What you'll notice is in both of these, I've got x plus 3 left over. If that happens, then this will factor to what I pulled out, x squared, plus what I pulled out over here, 2, together, times, they both have this x plus 3, equals 0. Now, I can set each of these separately equal to 0, solve. So x squared plus 2 is equal to 0, and x plus 3 is equal to 0. On the left side here, I'll end up subtracting 2 from both sides. So I'll get x squared is equal to negative 2. And if I were to take the square root to solve for x, I would get x is equal to the square root of negative 2, okay, which would be plus or minus I root 2. This is imaginary, which means that it wouldn't be a real solution. It'd be an imaginary solution. So I can immediately say, this is not what I'm looking for. Okay, what about over here? Subtract 3 from both sides. Okay, I want real solutions. So x equals negative 3. And I say, I'm not going to box that yet. I'm going to check my calculator. I'm going to go all the way back to the original. And I'm going to plug it into the left side because I've got an x on the left side. And then I'm going to plug it into the right side because I've got an x on the right side. And I should get the exact same thing. If I don't get the exact same thing, then it's not a true statement. And this would be an extraneous solution. So the cube root of x minus 5. So I've got negative 3 plus 5. What I'm going to do is negative 3 minus 5, sorry. What I'm going to do is take this to the 1/3. And that's negative 2. On the right side, I'm going to plug it in, negative 3 plus 1. And that's also negative 2. So because when I plug this in, this is a true statement, negative 2 equals negative 2, this is a solution. If I ever get a false statement when I go to check, say I would have gotten negative 2 equals 7. Well, those two are clearly not equal to each other, and therefore that's a false statement. Then it would be an extraneous solution. But because I get the exact same thing, then this is a true solution here.